All right, here we go. 7-4, solving polynomials. Our polynomials today are going to be in something strange. We call it factored form. And that's going to take a little bit of work to try to figure out how to make those, how to create that factored form. So we're going to break it into 2 days. First day, we're just going to solve their in factored form, and we solve it. And then the second day, we spend like working on how do I factor things, which is kind of like division. But a little reminder here. If you have two unknowns and are multiplying them together, and we know that the result is 0, then we know that one of them, I don't know which, right? One of them, either A equals 0 or B equals 0. One of the two things has to be true. This is why we want polynomials to be in factored form. And the key about factored form is this has to be multiplication. All right? So, key thing about this whole process, besides that time sign, is the fact that we have it set equal to 0. If a problem is not set equal to 0, please make it so. All right, step 1. 2 times x equals 0. This clearly is in factored form. We have it as a set equal to 0. We also see that there are 2 multiplications in between those. All right? So one of these 3 pieces has to be 0. All right, question number 1. Is this 0? And we say no. 2 is not 0. X. Could x be 0? Why, yes, x could be 0. And then, obviously, we ask it again. And in this case, x, we actually say is a double 0. Don't worry about that right now, but more on that later. So, example numero dos. Here now, again, we have the 0, yay. We have the time sign. It's in factored form. So again, here are my 2 pieces I'm multiplying. So number 1, x equals 0, or, now be careful what we write here. We say x minus 3 equals 0. Now that second problem needs to be solved a bit, isolated, simplified. So what we do is we add 3 to both sides and we get x equals 3. So here are my 2 answers, 0 or 3. Welcome to the world of what we call quadratics, where there are 2 solutions. Again, I think most of the problems day 1 here will have a nice 0 on that side. So you take each of the factors, there they are. Again, they're factors because we're multiplying, and we set each of them equal to 0. And you have to solve each of those little mini problems. All right, so solving the first one, x plus 5 equals 0, we subtract 5 from both sides, and we get x equals negativo 5. Here, second one, we got to do, it's actually a 2-step problem. We're going to add 7 to both sides. So 2x equals 7, and then we have to divide by 2. So we get x equals 7 halves, or 3.5. Either one is an accurate answer. All right, the third problem, and, well, almost final problem, is we have, again, factored form. It's kind of strange. We have a power of 2. So we proceed as usual. 3x plus 1, that, squared. So this, we'll just write it like this, or x minus pi equals 0. Let's actually solve the second one first. So add pi to both sides. That's just a constant, don't worry. So x equals pi. There's one possible solution. approximately 3.1415925. Enough of that though. Let's go to the second one here. Now I've got 3x plus 1 equals 0. Now again, I've got two 3x plus 1s, so it doesn't matter which one I pick first. I'm going to actually just end up erasing that. I'm going to ignore that piece up there. Yeah? And if 3x plus 1 equals 0, then 3x equals negative 1, and x equals negative 1/3. Now there's actually two answers here. And the reason is because there's two of these factors. So my answers are x equals negative 1/3 or x equals pi. Final example. They're not going to say solve, find the solutions. They'll say find the x-intercepts of the quadratic. So you need to think the same thing. Oh, I'm just going to solve it, like I did the last problems. Notice here now we have an equation. Notice it's not set equal to 0. So we're going to set it equal to 0. So 0 equals x minus 4 times 2x plus 8. So the first step is replace the y with the 0. Now proceed like you did the other problems. What is the first x-intercept, they call it? X minus 4 equals 0, so x equals 4. There's one x-intercept. And the second intercept is 2x plus 8 equals 0. Add negative 8, divide by 2, and we get negative 4. So I have two different zeros, two different x-intercepts, 4 and negative 4. More on that later. Again, an x-intercept, remember, is, this was the x-axis is the horizontal, and y is the vertical. So what we're saying is this graph goes through two spots on the x-axis, 4 and negative 4. Kind of crazy. It's a curve. This one in particular looks like this. All right. All right. Good luck in your homework, and tomorrow we'll work on factoring.